Hello guys, and welcome back to my channel Civil Construction and Tutor, and this is the continuation to the steel structure designing, and basically we are continuing the steel connection design. So in this video we will be designing the column beam connection, and for now we have a built up column and I-beam. You can see this in the extruded view. So this is the built up column and this is the I-beam. For the connection design we will need shear force and bending moment. As we are not releasing a moment for the beam, so we'll be designing a rigid connection. So basically there will be a moment connection, shear connection, gusset connection, splice connection, and these all have their own definition. So for moment connection there will be the transfer of moment from one of the member to the another through that connection. So here you can see this type of connection, so it is also a moment type connection. So we will provide this type of connection as well. Shear connection has the transfer of shear from one to another member. Similarly, gusset connection, this primarily transfers the axial force but also minor shear and moment. And basically gusset connection you can find that for the column and the base plate. And similarly we have splice connection, and that is used for connecting two members, that is for the continuity of the member. And basically the type of connection depends upon the structural design, that is during the consideration of designing whether the moment has been released or not. If the moment has been released, shear connection will be designed, else we have to design for the moment, and that is the main point we have to remember for the design. In the previous video of the truss connection we released the moment for purlin, that is why the moment at the connection or at the joint was 0 and we designed for the shear force only. But in case of this, that is beam and column, we may not release moment, so we have to consider that moment and shear force for the connection design. So here we will design the fixed type of connection, that is moment connection, and we'll also check for the shear connection. But firstly let us do the moment connection, and obviously we will have greater moment and shear force in this floor rather than this, so we'll check for the moment and shear forces here. Let us go to plan story 1, and here in the display frame forces select the envelope. I have already shown how to make this envelope load combination. So we have axial shear 1 2 3 and moment 2 3. So for the beam axial force shear 3 3 and moment 2 2 will be very less. You can simply visualize from the force here as well. So shear 2 2 will have certain greater value, shear 3 3 will be negligible, and moment 2 2 will be negligible, but moment 3 3 will be of considerable value. And here we have step number max and min, max min. So we will consider max first and then we'll also check for the minimum. If you do max and min, you will get both the values in the same diagram. So if you right click on the beam member, you will see this diagram and you can find the maximum and minimum. So for this connection we'll be considering shear 2 2 and moment 3 3. So let us see the maximum forces. So let's start with shear 2 2. So we'll consider one of the point and check the shear forces. So let us see here, right click on this beam. So we have maximum shear force of 60 kilonewton and maximum moment of 53. Similarly let us check for other as well, 48, 22, 45, 51, 24, 44. So here we had 60. So the maximum shear force is 60 kilonewton. Okay, here it is 61. And the maximum moment is, okay, let us click on the moment, and 45, 46. So the maximum moment we have here is for the 54 kilonewton. So this one has the maximum shear force as well as maximum moment, so we'll consider this particular connection. So for this beam and this column, and it is connected to the web of the C section or built up section. So we have to model that in the IDEA Statica. So let us open IDEA Statica, and here you have different type of connection. So this is for the beam and column, and you have two types of connection, that is moment and shear connection. So you can do one of them, but for now I'll consider a free geometry connection and we'll do manually, or even we can consider this directly. Okay, it will save our time, so we'll select this. So we have this continuous type of column, and we'll be considering a fixed or moment connection. So you can select one of them. So the generally used is this type, so we'll consider this, and we'll change the I column, that is the beam we are considering. So here you have I beam as the column, so we'll convert that into a built up sections. So for the column, here you have this is C, and here you can just add a new type of cross sections, and basically we don't have that listed, which is a built up type. So for this, simply you can go to plus here, add new, and in the welded or composed, at the last you have general steel cross section. So click on this, and you have to manually model that built up section. And for now we will consider a channel section, because our built up column considers the channel section, that is consists of two channel sections. So click on this, and we have, let us go define. Here we can find the built up section, modify. So click on here, and so we have two channel sections, and considering this as the origin, and they are spaced 100 mm apart on either side. So let us select ISMC 200. Okay, so you will find that in the window, and as I said, it is 100 mm apart from the origin. So for now the distance we cannot find directly because it is not shown here. So I will use a trick to make the space 200 mm. So here let me add a new component, and that will be the batten plate. So I'll model a 200 mm wide batten plate and check. So click on this. So width will be 200. Let me keep this as 8 mm. Okay, so I have to make this point come at this point. So let me move this point. So you can see here y and z. So I will make a displacement along y direction. So negative minus 100. So you can see it goes beyond this point. So let me make minus 90 minus. So it is a trial and error method. Now it is okay, and this base batten plate should be at this particular face. So it was 200, so the depth of this section will be 200, and it will be at 0 here. Then I have to make an offset of 100, but considering the thickness as well, it will be 104 in z direction. Minus 104. Now let me make a copy of this, or we can say a mirror of this. Copy, mirror about z, and it will be plus 78. We'll also make a copy of this. Positive 104. And actually we had considered 160 mm wide. So let me change that. So if you move to end, you can see here edit component. So let me keep this as 160. Okay, and for the other plate as well 160. So our section has been done. So For the connection, we have two beams connected to this column. One of this is connected at the flange side and another is connected to the web side. So we'll consider that. So for now we have connection to the flange side. So we have I-beam as well, and we have to check this as well. So we had this beam as ISMB 250. Okay, this is also ISMB 250. So the member connection is okay. So you can see here a warning that stiff one cannot execute the operation. Previously the type of column was a simple I-beam. That is why you could find the stiffener added. But in this general type, we cannot add that particular stiffener member inside it. So we have to uncheck this, or we can simply delete this as well. So this is the end plate which is used for the connection. Even the bolted connection for the end plate is not feasible. So we have to change that to welded, and we'll check whether it is sufficient or not. So for now, let us see the load. So we have the beam connected to the flange, and similarly we have a beam connected to the web. So we'll add a copy of this. Okay, firstly let us check with the connection that we have proposed is sufficient or not. So the load here we have the maximum minus 49 and 46, and here you have load effects. And for the member B, the model type will be N, Vy, Vz, Mx, My, Mz. We haven't released moment, so the model type will be this. So if we had released the moment, then we have to consider N, Vy, Vz. Now let us apply the load. So N is the axial load, we don't have to consider for the beam. Vy, so let me click the local axis. So Vy, we are not interested with this shear force, we are interested with the vertical, that is shear 2, and it is 49, 40. Okay, we can just take 50, taking an 50 kilonewton, and moment we'll consider My in the third direction, M33, which is 46. Let us take this as well, 50. So once let us check the connection also. So the end plate we have is connected to the member B, so that is beam, and connected to column, and the material is Fe250, thickness 10 mm. Okay, let us start with 8 mm. The connection type will be welded. You can simply see the connection here, and you can keep this as rectangle symmetrical, and you have to consider the dimension. So for now let us keep two profiles symmetrical. So you can see the dimension 62 mm from the top of the member. You can increase this if it is not sufficient. Left it is 0. If we keep this as 20, it will come out. So for now let us keep this as 0. So the minimum thickness of weld is 3 mm. For now it is 544. So you can see flanges. So the flange of the beam to end plate. So if you change this to a single front side, you can see here, so it is kept both side double fillet, and for the plate it will be a single fillet, and for the web of I-beam also will keep as double fillet. Now let us calculate. So you can see the connection is not sufficient. The plates, that is the flange, as it is a moment connection, so the flange is not sufficient considering the plates, and the weld, the utilization of the weld is also very much greater than the permissible value, so we have to revise the connection. So you can see we have failure in the top flange, so we can consider a stiffener at the top to revise this connection failure. So let us check that. For this, let me go to the operation, right click, new operation. I will consider a stiffening member and see whether it is sufficient or not. And I will also increase this end plate length to make the provision for the stiffener. So let me keep this as 80 for now. Okay, not 80, let me keep this as 100. And for the SM1, this is the stiffening member 1, the cross section for now it is taking as ISW 200, which I will take as a simple angle section. Okay, let me start with this thickness 8 mm, or we can simply take as 5 mm firstly. Let me keep this as 0. So the stiffening member is at the middle, so let me provide an offset. So in X direction and Z direction as well. Let me rotate this. So now I have to make the rotation in offset in the Y direction. So it is all about trial and error, so it will take little bit time to make the connection. So before that, for the end plate and the flange, we'll keep this as single fillet at the front side only, so that we can make the connection. $135. Still we have some gap. Okay, and in the Y direction also we'll keep this. Okay, EP1, let me give this as 110. So here we have to provide a connection for the stiffening member and the end plate, as well as the stiffening member and the top flange of the beam. So for that I will simply weld this, and for that right click on the operation, we have new operation, and here we have weld. Click on this. Now firstly I will connect the stiffening member to the end plate, so I'll keep the placement as is to surface. Type will be the weld. Member, so firstly I will select the member. So basically I want to connect the edge of this stiffening member to the surface of the end plate. So I have to consider the edge, so I have to consider the member of which the edge is to connect on the surface. So I have to connect the edge of the stiffening member, so I'll select the stiffening member first as the first plate, and you will select this member because it is a stiffening member. So I'll select member and consider the SM1 stiffening member. So this is the wave, so I have to consider the wave of the stiffening member to the end plate. And age index, so we can see the age index now. So this is the age 3, age 4, and similarly we have age 1. So I'll consider age 1, give space, then 3 space, and 4, and it is to be connected to the end plate. So for that we have to consider this is the plate, so EP1, and you can see here we have the weld now, but this is not the type of weld we want. We want a single fillet weld. So click on this, and now you can see the connection. So the wave of the stiffening member has been connected. Now let us connect the flange of the stiffening member to the top flange of the beam, and let us take the weld size as 5 mm, okay, equal to the thickness of the plate. So for now the thickness of the stiffening member is 8 mm, so let us keep that as 8 mm. Similarly copy this, and for the weld 2, the member or plate, it will be bottom flange and it will be connected to the member now. So it is the member to be connected is the top flange of the beam, and the edge were 1, 3 and 4, and it is connected. Similarly let us provide this at the bottom as well, else we might get a failure of the member. So let us try with it. So for that simply copy this, and we will just provide a pitch of 180 degree. You can see you will simply get the mirror image, and the weld will also be copied, and we have to change the member now. So it will be SM2 wave 1, and it will be connected to end plate 1, okay. Similarly for the weld 4, it will be SM2 bottom flange, and it will be connected to the beam bottom flange. So you can find the connection. And for the end plate we'll provide the thickness equal to its thickness. So end plate, the thickness we considered was 8 mm, so let us provide a thickness of 8 mm. Being a moment connection, the size of fillet may not be sufficient, so we'll increase that to 8 mm. For a wave it is not to be considered, okay, let us provide 6 mm for it as well. So now let us check. So still certain members are failing. So the weld of the fillet stiffening member is failing. Similarly the stiffening member is also failing. You can also check that from the check option here, and go to the plates, and here you will see the member which have failed. So it is the bottom flange of the stiffening member 1. So the stiffening member 2 is not failing, and similarly the welds. So you can see EP1, the end plate fillet is end plate weld is failing. Similarly the fillet weld that is considered for the end plate are failing. So let us go to design here, and firstly we'll increase the size of the stiffening member. So SM1, let us provide a greater thickness, so let us consider 10 mm thick. End plate, let us take as a 10 mm. So this was failing, so let us check with the thickness first. And stiffening member 2, 10 mm, okay. So now let us check. So now the connection is safe. So in this way we can design this type of connection. We can also propose other type of stiffening members such as triangular stiffening members, but for now I have used angle. So this is one of the connection type. So we also had a column in this face. So we also had a beam in this face. So you can simply add a copy of this and consider the direction as 90 or even minus 90. You will get the beam as per your arrangement, and simply copy this, and the member it will be M3 and connected to C, and add all these arrangement respectively. So now it will be SM3 wave 1 and it will be connected to end plate 2, SM2. Now we have to add the load, and for this we have 54 and 61. So M3 it is to be as 61 and moment 52, sorry, 52. So now let us check the connection. So the connection seems to be okay. You can simply check the analysis results. So all of them are satisfied within the permissible range. You can also check the deformed shape and check whether it is according to our load provision or not. So simply go to this and check for the deformed shape now. So I've basically increased the scale factor. So under the influence of the load 50 kilonewton, you can see here. Let us reduce the scale factor. So this is the type of deformed shape you will get, and you can simply prepare the report. So here you can find the size of the weld and all the status are okay. So in this way we can design the connection. So while designing the steel building, I had shown this image as well. So here you can see this type of connection. So it is also a moment type connection. So we will provide this type of connection as well. So let me uncheck all these stiffening members and I will provide stiffeners, or we can also say ribs. So go to operation, right click, new operation, and here you will find rib. Add that. So here you can see the rib. Now this is the width and this is the depth. So let us provide width as 60 and depth as 110. Now it is connected to the web 1. Okay, on the member B related to member C, end plate 1. Let us provide a thickness of 8 mm, shape triangular, chamfered or rectangular, that is up to you. Let us provide triangular. Surface on either side, so it is both. Location, center, rear, both. Front, or for now let us keep as center. So 2 numbers of stiffeners or ribs, so we'll provide 2 numbers, and let us provide an offset of 30 mm in negative direction, and keeping this as 60, 70 and this as 40. Providing an weld size of 5 mm. So now let us check whether it will be sufficient or not. Okay, for now we can provide end plate F1 for the flanges as double fillet, and let us provide 6, this as 5. So we can increase this to 8 mm. Okay, so we can also provide this type of connection instead of this.